Alright, in this video I'm going to cover how to do matrix multiplication. Oops, we lack an N here. I won't go into details about why it's defined the way it is. I'll do that in another video. So say we have a matrix and we want to multiply it by another matrix, and for just to make things easy, I'll choose a matrix with the same elements and dimension. So how is such a matrix product defined? Well, it's actually a little complicated and involved. So in order to make things clearer, I hope I'll make this little table here. So here I have the first matrix, this one, and over here I have the second matrix, and in this part here I'm gonna draw the product of the two matrices. So now I've filled in the elements of the matrices, and I gave them some color, and I changed the bold face of the numbers. Hopefully that'll make the procedure a little more clear to you. So let's try to calculate the product of these two matrices. So it's going to be a matrix here of it's a 3x3 matrix, like the two matrix factors here, and the first element here is computed as follows. So this is what's going on. You take the 1 and multiply it by this one plus 2 times 4 plus 3 times 7. In other words, you sort of take the scalar product of these two vectors here. You consider this as a row vector and this as a column vector, and you simply just calculate the scalar product or the dot product of these two vectors. That's actually what we have here. So let's just keep track of the result over here. So we have 1 times 1 plus 2 times 4 plus 3 times 7. That's 1 plus 8. That's 9 plus 21. That's 30. So, oops. The first element here is 30. Now for the next element, the one here, let's calculate that. So this is the result. You just need to hang on here. We take 1 times 2 plus 2 times 5 plus 3 times 8. So again, it's like taking the scalar product of this vector with this vector. So you consider this as a row vector and this as a column vector. You take the scalar product and you get this result. And let's just try to write down the numerical result here. 1 times 2, that's 2. 2 times 5, that's 10, so that's 12. Plus 3 times 8, that's 24, so that's altogether 36. So let's just try another element. I'll just divide this matrix into like 9 spaces, 9 entries, and let's try to calculate this element here. Now this should be the dot product of this vector here, this row vector and this column vector. So the result should be, and I won't use colors this time, 7 times 2 plus 8 times 5 plus 9 times 8. These are the numbers involved. 7 times 2, 8 times 5, and 9 times 8. I hope this is becoming clear to you that there's a pattern here. And the result, well, that's the result is 14 plus 40 plus 72. That's 54 plus 72. That's 100 and, well, that's 126. Oops, I shouldn't write it like that. So I won't do all the elements here, but this is the way to do matrix multiplication. It actually helps to, I think it helps to put it in this table here. It makes it more obvious that this row goes with this row, or this column, sorry, to calculate this element. And this row goes with this column, as we saw, to calculate this element, and so on and so forth. One thing to notice is that you can't do matrix multiplication unless these two dimensions agree. And what I mean by that is that the first matrix here in the multiplication must have the same number of columns as the second matrix has a number of rows. It simply follows from the way matrix multiplication is defined. Otherwise, it just won't add up. So if there are 3 columns, as is the case here, there must be 3 rows in this matrix. In other words, this over here is not a valid matrix multiplication. It can't be done because there are 3 columns here, but there are only 2 rows here. So when I try to do the first element, I would get 2 times 1 plus 3 times 2. I mean, that's this element times this element plus this element times this element, and then 4 times, and then there's just no element down here. So I can't do the multiplication and the addition due to the mismatch here. On the other hand, what I can do is this matrix multiplication. Because in this case, I have 3 columns here and 3 rows. So it doesn't matter that these 2 matrices are not of the same dimension, so to speak. This is a 2 by 3 matrix. This is a 3 by 2. I'm still able to multiply them. And the result would be a 2 by 2 matrix. I won't calculate the numbers, but and that's because when you multiply a 2 by 3 matrix by a 3 by 2 matrix, sorry, this should be across here. So the condition that must be met in order to make this multiplication possible is that these two numbers should be the same. That is the number of columns in the first matrix and the number of rows in the second matrix. And the result will be a matrix of this dimension 2 by 2. So in general terms, this is getting a little bit crowdy here, but I'll just make a frame over here. If I have an n by m matrix that I'm multiplying by a p by q matrix, well, then m and p should be the same number, and the result is an n by q matrix. Well, that's it for now.